Thank you very much, John. As John said, I'm Larsson. I come from a company called Makewave, and I also have this fancy title, VP EMEA of the OSGi Alliance. And I'm gonna go back to about 20 years ago, 20 years in time today, and explain a bit about the background of OSGi and how it looked 20 years ago. But first, I'm gonna do a quick introduction to Makewave. Then I'm gonna, after the going back 20 years, I'm gonna explain a bit about how you can actually build a system today if you don't have all the legacy that I have and several of the people in this room actually have. A few words of remote management. I'm gonna round off with a summary and some of the lessons we have learned during these 20 years in OSGi. So just a quick intro. Makewave, we make OSGi middleware. And we are perhaps known, best known in the OSGi world as the company that makes Snarplefish, or is behind Snarplefish. We also make a UbiCore, which is a remote management system for edge devices. We are located in Gothenburg in Sweden. Now, it was 20 years ago today. The OSGi Alliance dates back almost 20 years. I think it's going to be the 20-year anniversary next year. I'm not exactly sure about which date it is. And residential gateways were really the roots of OSGi, and that is where the name comes from, the Open Service Gateway Initiative. But the work started actually even earlier, and this was about the time I got into this space in the first place. This is a concept slide from 1997 about a concept Ericsson, the Swedish telco manufacturer, had developed. And they had a concept called the e-box. And that was going to be the electronic hub, or the brain of the home, connecting all your different devices in the home with services on the outside world. And it was going to run a web server, mini PC based, etc., etc. And they also had a maximum price tag of €500 back then, which was, well, that was what you expected to pay for these kind of device back in those days. I also found this old slide in this slide pack. It was a market outlook from '97, and IoT was not invented then. There was a concept called Things That Talk. I'm not sure if you remember that acronym. And I love some of these numbers here that, for instance, the last bullet, growing connectivity. Modem penetration in the US will grow from 16% to 25% in 1999. So it was a completely different landscape we were operating in back then. Broadband penetration was non-existent inside homes. You had dial-up modems, etc. Back then, this is around the time OSGi was founded, Ericsson developed a concept which they called the e-box system. And this is how their overall system architecture looked in 98, 99. In the home, you had the e-box. This is supposed to be the e-box, connecting all your devices inside the home. Then in the middle, you have something they call the service operator. That's the entity that operates or manages your smart home, your home gateway. And then to the left, you have different service providers that could provide different services. That could be home alarm, electricity, etc., etc. And they call this e-box also the service gateway. And this is the service gateway interface specification, one of the really, really early pictures of it. So the service gateway was the gateway between your local network inside the home and the wide area network. The service gateway consisted of a framework that ran a number of different services that had interfaces between them that would be standardized APIs. To the left, you had a management system, so it could be remotely managed. You had the device interfaces to your various devices inside the home, and of course, you could access this through various clients. For the service gateway, you need some kind of middleware. And that's the middleware providing the remotely controlled service platform. It should provide the lifecycle functions of loading, starting, stopping, etc. It should also be able to communicate with the other services, the local network, and it should live on top of a Java runtime requirement, and it should isolate the services from each other and also from the operating system. So this was the early requirements you had on the service gateway middleware. This was one of the boxes. Well, this was the box that Ericsson built, the eBox 101. It had a number of different configurations. The standard CPU was a 33 megahertz 486. I think it had 16 megabytes of RAM and 16 megabytes of flash. It had a serial port and an integrated power line modem, and a normal Ethernet slot as well for your LAN. And this was about it. And this was actually what we ran the first generations on OSGi on. So
it's unbelievable, isn't it? Because we had capacity. We ran Java server.
Everything, yes, Peter. We can take the discussion over beer later. So the eBox did set the original requirements, and I'm not going to explain how everything was, exactly how the alliance was formed, but this was a large part of the input in the formation of the OSGi alliance, and the eBox system requirements said, okay, we want a platform for the CPE device, consumer premises equipment. It should be based on open standard. Hey, let's form an alliance that can define the standard. It should be able to load software and services applications dynamically. You should allow for multiple service providers. It should be an open platform, but at the same time guarantee integrity between applications, so no sneaking between the different apps, and it should be remotely managed. And the result of this became later OSGi Release 1. But if you look back at this, and despite all the effort we put in, we managed to run this on very, very small, constrained devices that were actually quite costly back then. The vision we had was fantastic, but the market conditions was not favorable. They weren't simply there. We were too early for the market in '99. And I think there were three factors that really made it difficult for a huge success for OSGi in its first attempt to reach mass market. First of all, the bill of material for a residential gateway, it was quite costly. It was like 500 euros. I think it dropped slightly over time, but still it was expensive. And if you compare to it now, I'm not sure how is it. Is it less than 1/10 of the price, maybe 1/5? Yes, exactly. So it's really, really cheap now. Second one, wireless device technologies were quite scarce. There were some that were kind of starting to come out on the market, but they were also expensive and they weren't as easy to use as they are now. Now they are kind of pervasive and they're also low cost. So inside your home, when you wanted to install something like this, you had to retrofit. In many cases, you had to retrofit it with wires, and that is costly and it's painful and it's not easy to do. With wireless, you just put up your sensors wherever you want and you run. Third, but not least, you have the issue with broadband penetration. We use dial-up modems, and if you are old enough to remember the dial-up modems, they weren't fast. And the number of services you could run was quite limited compared to now. Now that you have, you don't have 100% broadband penetration in homes, but it's a huge number. And the kind of services you can run is completely different. But going back to this architecture picture from 98, 99, the whole concept which Ericsson developed, and there were other companies also having very similar architecture ideas and visions. This concept is actually used quite successfully, because if you think of it, what they defined was more or less the smart home market. So instead of a residential gateway, think of it that you have a smartphone, and on your smartphone you run a number of you run a huge number of apps. They're all managed by a service operator. In this case, it's just Apple. It could be something else. It could be Google, of course. And then to the far left, you have different service providers providing services through their Apple App Store. So this model is really a really powerful model, but it's been picked up by the mobile industry or by Apple almost 10 years later, or 6, 7 years later. The eBox system. slightly more successful. Their timing was right. They actually, this is also an old slide. They had defined payment models. So it was well defined how App Store purchases should be made, either directly through, and in this case, you would buy it directly from the e-box operator. So that what the e-box operator would be fronting. They also had a different payment model with app-in purchases. They had thought about that too. You buy the service or the function directly from the service provider, not through Apple. Looking at how we actually try to implement systems back in those days, if you go back to OSGi release 1, it was really down-to-earth kind of programming style. The service model was there. It's been there from the beginning, and it's very, very powerful. But back then, we used to services directly. So you need to manage and handle them by hand. And you had to use service listeners. That was the model. You had to, or everywhere in your code, not everywhere, but in many places in your code, you have to have service listeners that listens to service coming and going. It works, especially if you come from a C or C++ world. Then, I mean, you're used to dealing with things with on the lowest level, but it's kind of low level, and it's quite error-prone to handle all the dynamics. People must be aware that I got a log service, but it might be gone the next time I'm going to use it. And you have to take care of that in your code, and it's quite tricky. I think it was in release 2 we added the service tracker. I might be wrong. I'm pretty sure it wasn't release 2. Might have been release 3. I'm pretty sure it was release 2. Anyway, pretty quickly people realized that, hey, it's because of all this dynamics in OSGi, it's quite difficult to write code in an easy way. You have to write so much extra code just to keep track of all what's going on. So a concept of the service tracker was added, which makes it a bit easy to follow your services. So this is a service tracker for the HTTP services. This is just a very simple example. But over time, the declarative service model was introduced. Was it R4? It could be R3. Nevertheless, it's about 10 years ago. It came in between. You're right. But with the declarative model, you don't need to track your services the way you used to do. Still, however, in some cases, you have to take into account that in some cases things are coming and going, especially in the embedded world, where you could have devices being plugged in and plugged out, and that can be modeled as a service. So often you have to have, like in the example below, you have a reference coordinate, they're multiple, and they are dynamic. So sometimes you have to take into account that things are coming and going. So, end of history lesson, trying to take us going back to today, to 2018. So if you want to design a smart home or residential gateway solution today, how would you do it? And as you draw up the architecture picture, you actually often come back to this picture. This is actually quite powerful. This original design is usually what you go back to. However, some things have of course changed. You have the cloud. Instead of the wide area network, of course, you have a cloud. You have a cloud solution. Everybody has a cloud solution. And you must have an app. That's either to access an app that can control your smart home. Everybody has an app now. You must have an app. And also with services, instead of writing your hardcore services, you use declarative services, how you interact with them. But the fundamental thing is really still there. It's the same kind of architecture that you still rely on and you still use. So some of the things that have changed, well, as I mentioned before, the device technologies. You've gone out to a large extent from having wired to wireless devices inside your home. That's how you plug things together. The price of the gateway has dropped significantly. So they are, I shouldn't say they're cheap, but they are much less costly now than they used to be. Smartphones and apps, well, you need an app. Everybody has an app now for controlling your your smart home. And now I'm going to say a few words about a smart home system designed today by a company called Animus Home. So Animus Home is a Swedish startup. It's crowdfunded, based in Lund, down in the south of Sweden. And they have developed a smart home solution. Their gateway is called Animus Heart. That's the little white thing you see there in the picture. It's Linux-based, runs Snaplefish Release 6, Core and Compendium. And they have Bluetooth, they have Wi-Fi, of course, Bluetooth, Z-Wave, RF, and RF 433 megahertz supporting that. And their overall system architecture looks something like this. They have the Animus Hearts running a bunch of different services that can interact with local devices, be on the Z-Wave, RF 433, and Bluetooth. Their backend system is called the Animus Cloud. They have a smart home app, of course, and the Animus Cloud makes the management. What is new now is that there are many products coming out that are cloud-based. You have Alexa, you have Google Home, you also have Apple HomeKit. So Alexa has this concept of skills. I think Google Home has an equivalent. I don't remember exactly what it's called. So Animus Home has registered a skill inside the Alexa cloud or the Amazon cloud, saying that we have a device here that has those skills and that can understand these commands. You have the Alexa device inside your home that will transfer this request to the Alexa cloud. That will call back into the Animus cloud, which will make a request down to the Animus Heart, which can control one of the local devices on your RF433 device, for instance. So you could say, lights on, it goes through the Amazon cloud to the Animus cloud, down to the Animus Heart, out to the RF433, and turns on the light. Yeah, it's just a long way. HomeKit has a slightly different approach. So you can have a skill that you can broadcast out on the local network, saying, I have this capability, or I don't think it's called skill in that case. It might be called capability. I can do this, I can do this, I can do this. This can be picked up by a HomeKit device that I can make use of it. So that will be just local control in that case. It won't go over the cloud. So what you need to take care of, or what you need to take into consideration today when you design a smart home system, are all the cloud solutions that are out there. And you can't just ignore the fact that you have Alexas and Google Homes, et cetera, et cetera. So you need to take them into account. As I said, they run OSGi, in this case, Snaplefish. They have packages. As a package is a bundle, works pretty much like a device driver. It implements the OSGi device abstraction layer, and it provides additional APIs beside or on top of the device abstraction layer. But they will appear as a DAL device in the registry. They also have a concept they call the H app or HAP, which is a home app, and that provides the business logic of some kind. So it typically includes a UI and some functions for the end user. And all of this has been designed using declarative services. So this is an example of their dashboard, showing the dashboard of a home through their Animus Heart. They have put quite a lot of effort into an automation function that, based on certain events that happen, that could trigger other events. I'm sure there are similar solutions to this problem. So when something happens and this other condition is true, then turn on this light, for instance. So it's a rule-based kind of thing that creates automated tasks inside the Animus Heart. They have a mobile app for doing exactly the same things. If you are interested in what they do, their website is animushome.com. I can, of course, put you in contact with them if you're interested. In their development pipe, they have an SDK to allow third-party developers to develop H apps and packages. And also in the pipe is a full-fledged remote management. Right now it's image, they kind of replace the whole image on the heart if they want to make an upgrade, which is not uncommon. Going slightly outside the scope of the discussion, I just want to say a few words on remote management. And this is really some of the things we've learned during our 20 years in OSGi. And at Makewave, we have a product called UbiCore. And this is our product, that's our remote management system. And it's not currently used by Animus Home. They might not even use it, but I just wanted to share a few thoughts or a few things that we've learned about OSGi. So UbiCore is designed for managing embedded devices, embedded edge devices. It can either be an end user logged onto it, like a typical home gateway, but it can also work with a black box and IoT gateway out in their field somewhere. And the UbiCore server knows exactly which bundles are installed and running on these edge devices. UbiCore also pre-resolves and defines what needs to be installed. So you create a software package on the server and then you deploy them. And UbiCore is really in control. So the UbiCore server sends down a recipe to the gateway, and this saying this is exactly what you should run, alongside with the bundles. And it gets a status update back once the management agent has fulfilled the task of making an upgrade, for instance. So the management agent takes this recipe and makes sure that the platform of the gateway takes its medicine. This is the thing you should be running. In UbiCore, we also have something we call the OSGi firmware. And the OSGi firmware is really the framework and a core set of bundle, including the management agent. So that is the core functions needed to make a platform remotely manageable. That's kind of the lowest set of bundles you would need. We also have a concept of service applications, and this has been heavily debated in OSGi over the years. We found it very useful to be able to group bundles together that is performing some kind of logical function or service typically for an end user. As I said, we pre-resolve on the server, and we can sign the firmware's bundles and also the bundle configurations. We have a management agent on the edge device that's doing all the tasks. It's really connected with UbiCore, and it's also, normally the system is set up such that it's always the management agent that initiates the contact to the server. The management agent needs to know where the server is sitting. And it typically set up to check, are there any updates for me every n minutes? And that could be like every 10 minutes, every hour, or once per day, depending on what kind of system you're running. The OSGi firmware, that's really the core set of bundles and bundles configurations. They're packaged together as a single yaw, and that is what you would boot up. This is my core platform. The framework, very core services like event admin, CM, log, etc., and the agent. You can make OSGi firmware updates. So in this case, we've upgraded the framework and the new version of CM. We will provision the deltas, and we will instruct the agent to make a switch to a new firmware version. It can also restart the framework and or the JVM if required. The firmware versions can be installed, running, and failed. And we also usually have, or there's always a basic initial version, the factory setting versions. And you can, if an update fails, so you cannot go to this new version, it will throw an exception and it will revert back to the previous good version, and which could be the factory settings version. That's always good, or considered good. And you can keep any number of firmware versions locally, but typically you would have factory settings as the core default, the previous version, and the current versions. All bundles are stored locally as part of the firmware, and there's a bundle cache making sure there's only one jar file for each version of the bundle. Service applications. This is something we've used over the years. It's really a grouping of bundles. And it's something you group together as a functional unit or a logical unit, like an app. And this is what the gateway or the user subscribes to, or that gets installed or provisioned down to the edge device. And these service applications, they run on top of the firmware. So they don't include the firmware itself, but they depend on the firmware. A bundle can coexist in multiple service applications, so they can actually overlap, but there will only be one instance of the bundle started. So this is solved at resolve time inside Ubicore. So these are some of the concepts we have found be very useful for IoT solutions and home gateway solutions over our 20 years in OSGi. Getting back to the main track, OSGi and some summary of the lessons learned. OSGi, it's been around for 20 years, but it's still an excellent model for embedded device architectures. The fundamentals of OSGi are very, very good. It's an excellent design, even after 20 years. And the core principles still apply, I'd say. Also, what we found working with various customers in various fields, in most cases, OSGi guides you or pushes you in the right direction on to create a modular and service-oriented architecture. In most cases. Some cases, they don't get it, or it doesn't apply to their solution for some reason. But it's a very good mechanism or tool to get a good design in place. And many of the predictions and assumptions on smart homes and things that they were absolutely right. And I think we see that now starting to happen. But we were way, way too early in 99, 2000. And last but not least, a bundle developed for OSGi Release 1 still runs perfectly on Release 7 20 years later. I'm not done yet. Today, if you design a system today, use declarative services. It will simplify your things. Base the design on declarative services. It will kind of force or push developers in the right direction to design well-defined services performing well-defined tasks. And even if you have hundreds of different services, fairly large or very large complex systems, by keeping them well-defined and task-specific, these complex systems become manageable. It's not an easy task. If you have complex problems, you will have complex systems. It's complexity that doesn't go away with some kind of magic, but it helps. It's a good tool to manage this complexity. But still keep in mind or bear in mind that about the declarative and dynamic behavior. If you're not careful, component or service JOJOs can be created. It's all the problems still, they don't go away. So it's a powerful tool. It's really a powerful tool, but it can also sometimes be your worst enemy. So if you put it in the hands of the mad and or incompetent developer, you can create complete chaos. You have the dynamics, you have the service, it can be fantastic, but it'll also be a nightmare if used in the wrong way. But I think that's true for all powerful tools. If you give someone a powerful tool and he doesn't understand the tool, they hurt themselves. But always be aware of the dynamics and the multi-threading in OSGi. You have to understand it, otherwise you will end up in problems sooner or later. We also found that using third-party libraries usually works, it's usually great, but it sometimes can be troublesome. I think we discussed this at the BOF yesterday as well. They claim they support OSGi. Often they do, and they work quite nicely, but sometimes they just don't. They just don't work in OSGi context. And still, debugging DS is somewhat of a challenge from time to time. I think it has to do with the declarative model of things, that what happens is usually nothing happens, and then you try to figure out why nothing happens, because something hasn't been satisfied. And that can be more, you have to get your mindset right to understand where to start looking for the issues. And this can be, it's like a threshold you have to get over to understand that. So, that was it. It's not going to be... There they are.
Sergeant Pepper's Alien Heart Club. Any questions for Chris, or we have, you know, as long as you're not too hungry, we have time.
What's a JoJo? Yo-yo.
Yo-yo. Aha. Oh.
He spells it with a J, not a Y.
Aha.
This is a Y.
Aha. Okay. 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 In Swedish it's J-O. Okay. I thought we got it from. It sounded so English. It's not a Swedish word. Okay. Yo-yo. Okay.
We also call it yo-yo in German. And you put it at the end of the line.
He put that in there just to make sure you guys were paying attention. And you passed the test.
I think I've never seen it spelled. I only heard it said. So.
Any other questions? I think there was one here. Yes.
I think it's called recipe when you have some kind of bundles which you know will get updated.
Yeah.
Say you have a bundle X which is has dependencies to bundle A and bundle B, and you know that both need to be updated. Do you stop X and update both bundles, or do you make it sequentially so that X gets started once, stop, and then bundle B is updated and then started again?
If I'm not totally mistaken, that's configurable, but I think the default is to stop both first and then start them.
So you have it X started twice, or once for
Yeah.
update of
Yeah.
A and once for update of
Yeah.
B. That was the yo-yo.
Yes.